Hello, and welcome to another presentation video for KipwareM, a conversational CNC programming software for milling from Kentech Inc. You can see from the part on the print that we have a bracket that we're going to do some machining to. We want to spot drill and drill the 3 holes. We need to do a slot in the middle of the bracket, and then we need to do some contouring along the edge of the bracket. So we're going to dive right in. So the first thing I'm going to do is create a program up in the tree that's going to spot the holes. So I'm going to use the hole menu here. Probably would fall into line with some of the other patterns here. Maybe looks like it might be some kind of a bolt circle pattern, but I'm just going to use the random hole, and then we're going to create the program to do the spot drill for those 3 holes. So I'm going to call this my spot drill cycle. I'm going to pull down. I want a G81 cycle, so I'm going to select my G81 spot drilling. I want to return to the R plane. We've got a nice flat piece of stock there that we're going to use for this bracket. A coordinate of a Z clearance plane. I'm going to use that as ½ an inch above the part. The coordinate to start cutting, I'm going to use 50 thousandths above the face of the part. The coordinate of the total depth, so I'm going to go 200 thousandths deep with my spot drill. I'm not going to peck. The drilling feed rate I'm going to use is going to be 6 inches per minute, and no dwell time. So now what I can do is I can put in my locations, and you can see from our part print that the upper left corner of the part is from where all the dimensions come from, so I'm going to set that up as my part 0. And I'm going to use, so my first location, I'm going to use X of 3 inches and a Y of minus 1.1875. I'm going to use position number 2 is going to be X 1.125 and Y minus 2.750. And then my final location, number 3, is going to be my X of 3 inches and my Y of minus 4.3125. So I've got everything in there. I've got my locations. I've got my parameters for my spot drilling cycle, and then I'm going to hit Create Program. And you can see that the spot drilling cycle now has been added to my tree. If I want to make any changes to it, I can open it up, back up into the conversational menu and make any changes that I wanted to make. And what I'm going to do is, instead of doing that cycling, I'm going to use the copy command in KipwareM to copy all of the parameters that I put in, and then what I can do is just simply make a change to the cycle. So I'm going to copy the operation. I'm going to name it drilling. And now you can see that I have my drilling cycle in my tree. I'm going to open it up in the conversational menu. Everything is in here. And I'm going to change the cycle to a G73, which is a peck drilling cycle. My clearance planes are the same. The coordinate of the depth, I'm going to go 600 thousandths deep. The depth of each peck I'm going to use as 50 thousandths. My drilling feed rate I'm going to use as 5. And I've got all my locations. So now I can just hit Create Program. And now I have a drilling cycle that's up. So now I've spot drilled and I've drilled the bracket. So next thing I'm going to do is I'm going to rough out that pocket. So I'm going to use my rectangular pocket menu. I'm going to label this as rough pocket. And I'm going to fill in my parameters on my conversational screen. So the center of the pocket is 3 inches in X and minus 2.750 in Y. The top surface is 0. My clearance plane I'm going to put in as 100 thousandths. The length of the pocket in X is 1.5 inches. The width of the pocket is 750. The total pocket depth, since the plate is ½ inch deep, I'm going to go 575. The value of the corner radius is 1/4 inch. The depth of each cut in Z, I'm going to go 100 thousandths each time as I ramp down and go around the pocket. My ramp amount I'm going to input is 10 thousandths, and what this means is the tool's going to start in somewhere around the center of the pocket, but it's going to move over 10 thousandths. And as it goes down to each depth of cut, it's going to move X and Y 10 thousandths. So we're not going to get a plunge feed, we're going to get a ramping feed. The radius of the cutter, I'm going to use 1875. So I'm going to use a 3/8 end mill. I'm going to use 10 thousandths of cutter overlap. There's no finish allowance on the bottom because we're going right through. Finish allowance on the wall I'm going to leave as 10 thousandths. The clearance amount, X, Y, and Z, I'm going to use as 1/8 of an inch. The XY feed rate to go around that pocket, so I'm probably going to go about maybe 3,500 RPM, so I'm going to use 6 inches a minute. My Z-axis feed rate, this is going to be the plunging feed rate. I'm going to use that as 4 inches a minute, and we're not going to rotate it. It's actually a straight pocket along the XY axis. So I'm going to use this as my roughing cycle, and then I'm going to come back with another tool, another 3/8 end mill, and I'm going to finish the pocket. So I'm going to hit create program here, and you can see that my pocketing program now has been added. I'm going to use the same thing I did before. I'm going to use this as a finish. I'm going to finish the pocket. So now I've copied everything that I just made with the roughing pocket. I'm going to open it up in the conversational menu and select clockwise finishing, no roughing. These parameters will take care of themselves, so if there's a plunging or a depth of cut, the software is just going to ignore it because it knows that all we want to do is finish the pocket. We're not going to finish the bottom. I'm going to change my feed rate to 8 inches, and I'm going to change my plunging feed rate to 8 inches because there's not going to be any material there. I'm going to use cutter compensation so that I'll be able to adjust for the size of the pocket, and we're going to be going clockwise around the part. So I'm going to use G42, and I'm going to use offset 33. So in the machine's offset number 33, I will be putting the radius of the tool. I'm sorry, not the radius of the tool. I'm going to be putting any discrepancy between the 1.5 by 750 dimensions for the pocket. So this will give me a chance to allow the machine to use the cutter compensation to bring the pocket into size. So now I'm going to hit create program, and now I have a finishing pocketing cycle. So we've spot drilled, and rough pocket. I'm just going to see how I'm doing with this, and I'm going to bring it into the plotter and see how it looks. There's a couple of ways that I can plot the program in Kipware TP, which is the companion application that's integrated into KipwareM to do the toolpath plotting. If I select this icon here, this will plot individual cycles that are in the tree. If I press this icon here, this will plot all the programs in the tree. So no matter what number of programs you have in the tree, it'll automatically create a plotting file and plot them all together, which is pretty much what I want to do in this case. So I'm going to go there. And you can see when Kipware TP launches, in the plot box are all the G-code programs that have to do with those programs that were in the tree. A couple of neat things that I can do in Kipware TP. One of them is that I can use a stock model DXF file as a stock model, and then I can plot the toolpath directly over the stock model. So I'm going to go and get that sample that we have. I have a DXF file of it, so you can see I have my pocket, and I can relate my toolpath plotting to actually what's going to happen on the screen. And a couple of other things that we can do. One of them is that we can create a library of tools that we want to use when we plot. So you can see that we can have turning tools, milling tools. In our case, we have a 375 end mill, and we have a 250 end mill. I'm going to use the 250 end mill as the drill just to give me a diameter. So what we can do is you can create any type of tools, as you can see from the form, and keep it in the tool library, and then you can automatically have those tool shapes displayed when the tool path gets plotted. So the first thing that you would do is make sure that it's in the library, which we do, and then we can make a plotting tool list. And what happens is a plotting tool list contains a trigger code and then a tool that you want to associate with the trigger code. Normally, if you were plotting a real G-code program that's complete, you might have tool 1 is one tool, tool 2 is another tool. In our case, all we have is some G-code program here that's pieces of the cycle. So for the trigger code, I'm going to use, in this particular case, I'm going to use a spot drill. So the software will look for this inside the program and then automatically associate that 250 end mill with it. All I have to do is double click the tool from my tool library list and associate it with that. The other thing that we're going to do is we have a rough pocket inside this program, so I'm going to associate that with the 375 end mill. So I can set this. You can also save this tool list so you can bring it back later, or if you have tools in your carousel of your machine that's kind of stay the same, you can set up a tool list and then you can keep loading that tool list with the specific trigger codes. But I'm just going to set this for now, and then I'm going to turn it on. So this means that I'll actually show the tool when it gets plotted. So I'm going to hit the milling icon, which is going to give me my toolpath plotting. You can see I have my 3 holes, and I have the pocketing being done by the 3/8 end mill. A couple things, other things that you can do single block. So if I want to watch the tool and watch my Z vision to make sure that I'm in the right place, I can do that. Here we go with the pocketing. And you can see by the Z vision that we're down inside the part. And we're going around the part, roughing out the pocket. So I'm just going to quit this. Those are a couple of options that you can use in Kipware TP. For our demo example here, our 3 holes are in the right spot. The pocket looks like it's in the right spot, so we can keep going with our program. We're satisfied that everything is in the right shape and in the right place. So there's one more operation that we have to do to the part, and that is mill the contour at the end of the part. That doesn't fall into any of the conversational menus. It's not a standard shape, so we have to use the SketchPad in order to machine the end of the part. So I'm going to get my SketchPad started, and what I'm going to do is I'm going to go get the DXF file that I had of this particular part. So it's in my temp folder. And here's my part. There's a number of ways that we could do this. One way is if you want to program, this is actually the shape of the part, so if you want to program the actual shape of the part and use cutter compensation to be able to adjust for the size of the end mill, you could do that. I'm going to show you a couple of things. That's probably the way I would do it. That would be the quickest way to do it. Is basically all you have to do is pick a start point, pick an end point, tell it the size of the tool, and then you've got your tool path. But I'm going to kind of do an example where I can show you how we do some drawing here and incorporate that into what we're going to do. So what I'm going to do is I'm going to offset this the size of my end mill, and then I'm going to draw what I would consider to be the tool path to be able to do that. So I'm using a 1/2 inch end mill, so I'm going to offset this tool path by 255. So it's going to leave me 5 thousandths for finish. And what I'm going to do is I'm going to start here, draw a line in the arc, and then end up in here somewhere. I don't know any of these points, which is one of the neat features of the SketchPad, is we can use a feature in the SketchPad called AutoPath. And basically AutoPath will automatically calculate these tangency points. So as long as I know the start point and the end point and the angle of the lines, the radius of the fillet, the software will do all the work for me. So basically I'm just going to start to draw. I'm going to start about 1/4 of an inch off of this end, and then I'm going to draw a tool path that would show up as the center line of the tool, the 1/2 inch end mill, 255 away from the finished shape here. So we're going to dive right into the drawing, and before I can do it, I need to do some calculations so that I can figure out a start point here where I can draw my tool path. Normally you could just use the elements that are here in the drawing from the DXF. But I want to show you how you would draw in the SketchPad. I want to show you a feature called AutoPath that's in the SketchPad that will automatically do calculations for you, whereas these tangency points from the print, we don't know where those are. The only thing we know is this point and the angle of these 2 lines. And that's sufficient enough in the SketchPad to be able to draw this tool path. So what I want to do is I want to calculate an offset of 255. And you can see on the screen that we have a little triangle there. You know, trigonometry is very important in CNC programming. So we're going to use those that little triangle there to come up with my X and Y leg that I need to offset so that I can get a 255 offset of the part, which would be the half the end mill and the 5/1000 left for clearance. So I'm going to go back to KipwareM. I'm going to get the Kipware TB option going. This is our machine shop toolbox that comes standard with Kipware Conversational. And I've got my right triangle calculation. So I know my angle is 40 degrees because the angle of the line is 50 degrees. So 90 minus 50 is 40 degrees. And I know my offset amount is 255. So I can calculate the unknown, and I have 1953 will be my X offset, and my Y offset will be 1639. So armed with those 2 points, I can go back to the sketchpad and begin my drawing. So I want to start in this corner and go in this direction around the part. And the way the sketchpad works is it works with element symbols. So basically I just need to find the direction of the line that I want to draw from here up until here, and I want to start with this element right here. You can see there's some leftover numbers in here from when it imported the DXF, but it doesn't matter. So I want to go with a polar line because I don't know too much about that line. The only thing I know is the start point, which is 6 inches in the 1954, which is what we calculated using TB. And the X is in the Y, is going to be the 5.5 plus the 1638 that we calculated in TB. So that's going to be minus 5.6638. The angle of the line, I do know that's a 50-degree line. You can see from my sketch here that everything starts at 0 just like any normal CAD program and goes around. My line is coming up in here, so it's 50 degrees. I don't know the length of the line, so I'm just going to leave it, and I'm going to employ the autopath feature in the sketchpad. So basically what happens is the software records that element and says you can either input a next element or you can use a fillet as you keep drawing. And I'm going to use a fillet, and I'm going to say that it's a 1-inch fillet. And then I'm going to put a line going in this direction, which is going to end up in here. So I'm going to input a line that's like this. You can see from my highlights here what the software is looking for. It's looking for an endpoint in X, which is going to be the same, 6.1954. And the Y, 0 is the top surface here, so this is going to be 1638. So when I give it the angle of the line, which is coming around this way now because the line is going in this way, so it's 180 minus the 50, so that's 130 degrees. And I can see when I hit the autopath feature that it automatically calculated for me the tangency points, and I have my 255 offset to be able to create my toolpath now and rough the part. So now we can create the toolpath to be able to rough the part. So I'm going to turn on my element list. And the way the sketchpad works is we need to start with a starting point, a starting element, and tell it what the ending element is. So if you were going to machine this whole contour down here, you could pick a starting element and an ending element, and then the software will automatically join them together to create a toolpath. What we want to do is we want to start down here. So I'm going to find that element, which I'm assuming is the bottom list here because these were all that was imported through the DXF. And you can see this is my start point, and it's highlighted by a circle in the highlight of the line. The circle indicates the start point. So the start point is going to give me my direction. If I want to go from here up against this line in this direction, so this is correct. If you wanted to change this for some reason, or you wanted to just mill some, you can use the reverse. And now when I look at the element, you can see that the circle is here, which indicates the start point, and this would be the direction of the cut. But we're correct where we were. I'm going to just put it back. So we want to start here, up along this direction, along this line, and now I need to find the end point. And the end point is here. So first of all, what I want to do is when I find the start point, hit the traffic signal. This is the go light. This means this is my starting point. This is the direction the cutter is going to move. This is my ending point. And on the ending point, the circle or the direction of the line isn't really relevant because the software knows that you want to go this way, and it's automatically going to join it and go in the correct direction. So even though this is correct here with the circle being in this direction, it's not really relevant. You don't need to worry about it. This is the ending element. So I'm going to hit the stop sign, which tells it that this is going to be the ending element. So this is my toolpath. The software will, if there was more elements in here, but what it's going to do is it's going to join everything together automatically and make a toolpath. So I have my start point, I have my end point. I can now select that I want to make a milling toolpath. And SketchPad gives you the opportunity to make a complete G-code program with tool calls, post file, offset calls. We're not really going to be interested in any of this right now because we're going to make a piece of the program that's going to go into the tree. So we'll get our tool calls and our spindle calls going later when we create the main program. So I'm going to give it a rapid plane of 1 inch. Top surface of the part is 0. The part's 500, so I'm going to go 575 deep. With a close clearance plane of 100 thousandths. I'm going to give it my RPM. My depth of cut is going to be 100 thousandths. My cutter diameter is 1/2 inch. My plunging feed rate, I'm going to give it as 10 inches a minute, and my cutting feed rate, I'm going to give it as 12 inches a minute. I'm not going to use cutter comp in this particular case. I'm just going to use the center line of the tool to rough the part. I'm not going to give it an approach direction. I'm just going to plunge right on this corner here, and I'm going to go around the part, and I'll clean it up when I finish the part. So what I'm going to do is I'm just going to hit Create Program, and this little piece of the program now gets written for me. You can see we've got depth of cut here, 100 thousandths, then 200 thousandths, 300 thousandths, as we take the material away from the edge. I'm going to save this as a KipwareM op. I'm going to save it as rough contour. And now that piece of the program is done. So we have our roughing toolpath done, and now I'm going to create the finishing toolpath. And I'm going to use the actual part to show you how you would do that when you just import a DXF file and you want to use those elements to create the toolpath. So I'm going to just clean up my drawing a little bit. I'm going to get rid of those lines that I drew, and now I've got just the part that I'm going to use. So again, it's just like roughing the toolpath, and we want to find the beginning element, which is this element here. And again, it is going in the correct direction, so I'm going to set this up as my start point. I'm going to find the ending element, which is this one. And again, you can see how the circle is not really correct if this was the starting element, but the ending element doesn't matter. So we're going to hit the stop signal to tell it that this is my end point. And then I can create my finishing toolpath. Some of these dimensions are left over from the roughing. I'm going to change my RPM. I'm going to change my depth of cut to 575, so it'll do it all at one cut. I'm going to leave my plunging feed rate the same, but I'm going to change my finishing feed rate. And in this time I'm going to use cutter compensation. So what I want to do is I am programming off the part. And so the center line of the tool would be riding in here, and obviously it would be too small. So I'm going to use the cutter comp offset in the machine to give me an opportunity to cut the part, but yet have the offset ability to bring the size of the part into play. So I'm going to use G42 because this is the direction that the cutter is going to be moving, and I'm going to use offset number 30 at the machine. So automatically the software is going to input a move that's going to get the cutter compensation active before it starts to hit the part. And what I need to do is I need to create a tool approach direction. And which way do you want that startup block for cutter comp to go? Normally you want something that's kind of smooth into the part, so I'm going to come from out here, go into the part, and then go around the part and finish the part. So I've got my approach direction here. Everything else is done. Hit Create Program. And now I got my finishing program. You can see I have my G42 and I have my offset call. So at offset 30 at the machine, I'm going to put in the radius of the tool and then use that offset to compensate for the size of the part as I go through and actually machine the part. So I'm going to save this one now as a finish contour. And now that piece of the program is done as well. So I have my roughing toolpath and my finishing toolpath. So closing out the sketchpad and coming back to KipwareM, I need to be able to get those two cycles that I created into the tree. So I'm going to open it up, and I'm going to get rough contour, and then I'm going to open up and I'm going to get finish contour. So I have my rough and finish contour now as part of my program. So I'm going to launch Kipware TP, and I want to plot everything in the tree, so I'm going to use this icon here to get it going. I have my DXF stock model loaded, and I have my tooling. Just make sure that I have my tool turned on, and I'm going to hit the plot button and we'll see what happens. So we've got the 3 holes. We've got our pocketing, and you can see from the Z vision where we are in the pocket. So we're ½ inch, now 550, now 575. Then we come back and we do our contour, same thing, we're coming down 100 thousandths. And then we've got our finish plot, which is directly on the part, so we're going to use the cutter comp offset at the machine to be able to allow for that size, but everything looks pretty good. So we did a good job with the program. The plot looks good, everything's in the right place and looks to be correct. So I'm going to launch the main program option in KipwareM, and you can see that I have all my pieces of the program, all my cycles on the list on the right, and now I can make operations. So what I'm going to do is I'm going to select operation number 1. I'm going to call it tool number 1, G54 offset. My spindle RPM for my spotting drill I'm going to use as 3500 RPM. Going to use offset 1, and then my clearance plane I'm going to use as 1 inch above the part. And basically what this does is, where is the tool going to come down before it starts to do the machining from the cycle, and 1 inch above the part will be fine. So now I can select any of these programs that are in the cycle list by double clicking it, and you can see we can have up to 10 different programs in here linked with that tool. So for instance, let's say you wanted to do the rough pocket and the finish pocket with the same 3/8 end mill. You could do that. Just double click them both. You'll have 2 cycles in here, and the software will automatically do that cycle and this cycle with the same tool. In our case, all we want is the spot drill, so that's good. Tool number, we're going to go to operation number 2. Tool number 2, G54. A spindle operation for my drill I'm going to set as 3000 RPM. I'm going to use offset number 2, and then my clearance plane is going to be 1 inch still. So now I'm going to hit the drilling and add that to tool number 2. Tool number 3, so work offset G54. This is going to be my 3/8 end mill, so I'm going to go 2500 RPM with that. I'm going to use offset number 3, 1 inch above the part, and I'm going to rough pocket it. Just to give you an example of what it would look like, so if I double click finish pocket, you can see now that this is added to this tool too. I could do any number of cycles that are in this tree with this particular tool. In this case, I just want to do the rough pocket with tool number 3. And again, we're just going to keep going through the part. Tool number 4. Again, the spindle RPM, this time 2800 as we finish the part. Operate number 4 and as clearance plane. So I'm going to double click finish pocketing here. And then we're going to go to 5. Tool number 5. This is going to be my ½ inch end mill. That's going to come in and it's going to rough the contour. Then tool number 6 is going to finish the part. And we're going to finish the contour. So I'd give it a program number. I would select a post that I want to use. We've covered posts in other Kipware training videos. And then I'm going to hit create G-code. So here's my program. Everything's linked together. I've got tool number 1, which is doing my spot drilling. I've got tool number 2, which is doing my drilling. Tool number 3, which is doing my rough pocketing, and so on as we go through the part. Here's my finish contour with tool number 6, finish contour. So there you have it. We have one big program. This is the program that you would send to the machine. It has all the tool calls, all the G-code from those cycles that we created inside the program. So this is the one complete program that you can send to the machine to machine the part. One thing to mention about programs and cycles that you create, and you've seen how we've saved the cycles. Every time you create a cycle, it automatically gets saved to the folder. But what we can also do is we can save the program. So if I name this program, in this case I've named it Demo Program, when I save this program, And let's say I exit the software and come back in at some other point. So I start the program and it's blank. If I go and I get that program that I created, that demo program, you can see that I have all my cycles come back. If I go into the main program feature, all my operations come back. So if you had sent it out to the floor and then you need to make a change, let's say you want to change this contour feed rate, basically you can just bring it back in and you can make any changes. Let's say we wanted to take this rough pocket and we wanted to make the depth of cut a little bit less. Let's say we make the depth of cut 50 thousandths. Make a simple change like this, hit create program. It's going to update that part of the program, that pocketing program. Then we can bring it back in here. All my cycles, all my operations are right here. When I hit create G-code, I have a brand new program with that rough pocketing now at 50 thousandths depth of cut rather than the 100 thousandths that we had before. So very easy to change things in the cycles, very easy to change things in the tree. Save the program, bring it back. You can do pretty much anything you want either in the conversational menu or straight in the G-code program right here in Kipware.